All right, so we're going to be, these are practice problems for finding the missing side in similar figures. To do that, you need to set up a proportion in order to be able to solve it. So I'm going to start with my ratio, word ratio, and I'm just going to call this the small triangle and the big triangle. So small and big. Set up my boxes. So in the small triangle, I'm just going to pick a side, 14. And in the big triangle, that side corresponds to the x. All right, then I'm going to go back to the small triangle and pick a side. That would be 12. It corresponds to the 12 in the big one, so 20 goes here. All right, to solve a proportion, I'm going to use cross products. So I'm going to multiply diagonally 14 times 20. And that gives me 280. So 280 is equal to 12 times x. All right, I don't know what that is. I can't multiply those, so I'm going to work backwards and divide. So if I divide 280, I'm going to run out of room. 280 by 12. 12 will go into 28 twice. It gives me 24. When I subtract, I get 4. Bring down the 0. 12 will go into 40 3 times. That's 36. When I subtract, I get 4. So I have a remainder. I'm going to add a decimal and a 0. Bring that down. 12 will go into 40 3 times again. 3 times 12 is 36. And I can see that the remainder is repeating, so then this is going to cause the quotient to repeat as well. So I put a line over that 3 to show that it's going to keep repeating. So I can say that x is equal to 23.3 repeating, and this is going to be measured in inches. So 23.3 repeating inches. All right, in the second problem, I've got 2 rectangles. So I could do small and big again, but I'm going to use sides this time and compare the short side to the long side. There's often several ways to set up a proportion. Just be careful that you keep your numbers in the right spot according to your ratio, your word ratio. So let's see. So the short side in the first rectangle is a 3. And the long side in the first rectangle is 22. And then if I go here, the short side in the second rectangle is 1.5. And the long side is y. All right, to solve it, I'm going to multiply 22 times 1.5. 5 times 2 is 10. Carry that 1. 5 times 2 is 10 plus 1 is 11. Start with a 0. 1 times 2 and 1 times 2. When I add these up, you get 330. There's a decimal here, so since there's 1 here, there has to be 1 here. So this is going to be 33 equal to 3 times y. So to solve this now, I'm dividing by 3. So if I divide 3 into 33, it's going to go 11 times. So y is equal to 11, and I'm measuring this in meters. So y equals 11 meters. All right, in the third problem, I'm going to do, I think I'll do short to long again. Short side to long side. So the short side in the first rectangle is 2.4, and the long side is 12. In the second rectangle, look, you can tell that they've rotated this, so now the short side is on top here. The short side is 4, and the long side is x. All right, to solve this, I'm going to multiply 12 times 4. I know that that is 48, and that's equal to 2.4 times x. All right, I don't know what that is, so I'm going to have to divide by 2.4. So when I divide 2.4 into 48, okay, I can see there's a decimal in my divisor, and so I need to make that into a whole number. So remember fox and rabbit, I'm just going to move it over once till it hits that wall. Here I need to move the decimal also. The rabbit's running away from the fox. But there isn't a decimal, so I add a decimal on the 0 and move it over one place. So now I'm actually dividing 24 into 480. 24 will go into 48 twice, and I get 48, which is 0, and I'm going to bring down a 0. Okay, and because I brought that 0 down, I have to go ahead and finish dividing. 24 won't go into 0, so I have nothing remaining now. So my answer is x equals 20, and I'm measuring that in centimeters. All right, and the fourth problem. If anytime you need to slow down or pause the video to catch up with me, please do. I'm just trying to make a shorter video for y'all so you don't have to listen to me for too long. Okay, and the fourth problem, this one, I'm going to call it, how about we call it the diagonal side compared to the, oh, looky here. All right, so there's a mistake on this one. I can see the diagonal sides here are 18 and 10. They've rotated this triangle as well. And they want me to solve for x, which is the short side. But here they gave me the long side, not the short side. So technically, I can't solve this problem based on the information they gave me. And because it's only corresponding sides that are proportional. And I don't know the corresponding side for x. So that's a mistake. That was my bad when I made the worksheet. So what I'm going to do to fix this is just move the x to over here, because now I can say that the long sides are corresponding. All right, hopefully that made sense. So I'm going to do diagonal to the long side. So in the first triangle, the diagonal is 18 and the long side is 9. And in the second triangle, the diagonal is 10 and the long side is x. So now when I solve it, I'm going to multiply 9 times 10, I know that's 90, equal to 18 times x. All right, to solve this, I need to divide 18 into 90, and that will go 5 times. So x is going to equal 5, and this is measured in inches, so 5 inches. But remember, x has to be this long side here. I can't actually solve this for the short side. I don't have enough information. All right, on number 5, and this is one of those problems where I'm solving for 2 different things. So that's going to take 2 different proportions. So make sure you're using the sides that are proportional and that you know. So I'm going to call this, let's say, big to small. These are trapezoids, big to small trapezoid. So I need to use a ratio that I have both values of. So I can see that they told me the top in both of these trapezoids. And so I can use those. And then I need to solve for x. So I can see that this slanted side here corresponds to the x. All right, so in the big trapezoid, I'm using 15. It corresponds to the 3. And then if I go back to the next side, the big trapezoid is 20. That's corresponding to x. I'm going to set this up and solve it. 3 times 20, I know, is 60. That's equal to 15 times x. And you can write, when you have a number and a variable, to show multiplication, you can just write those next to each other. You can use that dot, or you can use parentheses. So I'll go ahead and put in parentheses because I know we're used to seeing it that way, but you could also just leave it without the parentheses. To solve this, I'm going to divide by 15. So when I divide 15 by 60, I'm going to get 4. So x is equal to 4 centimeters. And then I have to start over to solve for y. So again, I'm going to use big to small. So I'm going to keep that first ratio the same. I'm going to go back and use the same. 15 in the big corresponds to 3 in the small. But this time, I want to use these 2 sides to solve for y. So in the big trapezoid, I'm going to use 25. And the small trapezoid, I'm going to use y. Then to solve it, 3 times 25, I know that that is 75. 15 times y. Again, I can just write it like that, 15y. Or I can put it in parentheses. And to solve it, I divide 15 into 75, and it will go 5 times. So y is equal to 5 centimeters. All right, and problem number 6, I'm going to go ahead, and it looks like they gave me more information in this one than I truly need, so sometimes that's helpful and sometimes that's confusing. So I'm just going to be careful. What we're doing here, I need to solve for x. I need to make sure I'm using a corresponding side to x. So x is across from that one little arch here. So if I'm not sure how they twisted this, I can see that across from the little arch, one arch here has one line, is the 1.5. So I know that these 2 sides are corresponding. So I'm going to call this the big triangle and the small triangle. And in the big triangle, I have x. In the small triangle, I have 1.5. Okay, then I need to pick another side to finish my proportion. So I could do this side. If this side, I need to figure out what it corresponds to in this triangle here. And I have these two choices. So to know for sure, I can look at the angle it's across from. So this side is across from this angle that has the two little arches here. So if I look at this triangle here, I want the side across from the two little arches, because I know that these arches mean that these angles are the same. And so the sides across from congruent angles are the corresponding ones. All right, so these two arches here, so that was 6, so this would be 3.6, so these are going to be your corresponding sides. Sorry, I usually make that a box. Okay, or I could use the diagonal sides, and those are also corresponding, but I don't know, it's an extra decimal, so I'm just going to use the ones I have. All right, so in the big triangle, I'm using 6, and the small one, 3.6. To solve these, I multiply 6 times 1.5. I get 90, but don't forget about this decimal, 1 here, so 1 here. So 9 is equal to 3.6 times x. So I need to divide by 3.6. So again, I need to move this decimal in the divisor over one space. So I need to add a decimal and a 0 and move it one space here. So really dividing 36 into 90. 36 will go into 90 twice. 2 times 36 is 72. When I subtract, I get 18. All right, and so since I have a remainder, I'm going to add a decimal, both places, and a 0, bring that down, and keep going. 36 will go into 185 times. Yeah, and that's my answer. So x equals 2.5, and this time they didn't give me any units, so I'm going to leave my answer as 2.5. All right, in the last problem, I'm going to call this the big trapezoid and the small trapezoid. I am solving for x. I want to make sure I pick the sides that correspond to the x, because they've given me all the sides here. I really don't need all the sides to solve. I just need 2 sets of corresponding sides. All right, so x is going to correspond with 4. So in the big triangle, 4, and the small triangle, or trapezoid, sorry, is x. All right, then I need to pick the side that corresponds here. So 4.5 would correspond with the 6 here, so those are the two I'm going to use. So in the big, that was a 6, and the small, that's a 4.5. Okay, so start by multiplying diagonally. 4.5 times 4, that's 20, carry your 2. 4 times 4 is 16, plus 2 is 18. 1 decimal here, so 1 decimal here. So 18 equals 6 times x. Okay, and then to solve it, I divide by 6. So x is equal to 3, and again, I don't have a unit, so my answer is just 3. All right, so that's, oops, sorry if you couldn't see that. That's solving for missing sides using similar figures and their corresponding sides, which have to be proportional. Thanks.